So here's our first example that we're going to use to demonstrate Simpson's rule and trapezoid rule. The interesting is this first example, obviously we do not need a fancy technique, right? This one you can actually use the fundamental theorem of calculus, but I'm doing this example so we can actually check our answer. We can do it with integration, we can do it with Simpson's method, so we can see how close we got to the actual answer. But rest assured, like some of the examples we're going to do in a minute, let me show you what they will look like. It will look like something like this, where use substitution does not work. This is really where you need Simpson's method and trapezoid method. Okay, but the first example is just to demonstrate that we will get the answer you expect to get. So before I even jump into the messy calculation with Simpson's and trapezoid, let's first do this with fundamental theorem of calculus. What would this integral be based on the fundamental theorem? Thanks to Mr. Newton and Leibniz, who gave us this nice, easy rule to integrate. So first you find the antiderivative of x cubed, right, which is x to the 4 over 4 going from 0 to 2, right? We take the antiderivative, plug in the limits, and what do we get? 2 to the 4 is 16, minus 0 to the 4 is 0, so we're getting the answer is 4. So for this question, we have the advantage of knowing the answer in advance. And in a little bit, we're going to apply Simpson's and trapezoid method, see how close it gets to the actual answer. For this question, I want you to use only four rectangles. I hesitate, I say rectangles because they're not really rectangles. They're rectangles with, either they're trapezoids or rectangles with parabolic tails. We're going to use 4 of those entities, whatever they may be, okay? Okay, first thing we do is, as always, we get what delta x is. Since the question said use n equals to 4, the rule is b minus a over n. Okay, in this case, b minus a is 2. 2 over n is going to be 1/2. So this is our delta x, 0.5. Okay, any questions about that? What delta x is? So they must give us what n is, okay, guys? Otherwise, there are so many ways to do it. You could do 8 partition points. You could do 20. They need to tell you how many you should use. To find delta x, we just go to length of the interval divided by n. In this case, it's 1/2. So basically, what we're going to do is, if the interval is from 0 to 2, we're going to start at 0, then keep adding 1/2. Like then the next point is going to be 1/2. Add 1/2 again, you get 1. Add 1/2 again, you get 3/2. Add 1/2 again, you get 2. Do I stop? Where will I stop? You stop when you have reached the upper limit of integration, right? The upper limit of integration was 2, and we stop there. Okay? So the points we got are, starting with the left end point of the integral, 0. Keep adding the partition points, so 1/2, 1, 3/2, and 2. Why did I stop here? Because that was the upper limit of integration as we had over there. And you have to start at the lower limit. If it started from 1 to 2, you would have to start at 1 and then go up based on that. Okay, now we're going to do it with a tabular approach, which just makes things a little bit easier for us. Now, remember that in every formula, we had something like f of x sub 1, f of x sub 2, f of x sub 3, etc. This point here is x sub 1, this is x sub 2, x sub 3, and this is your x sub 4. Okay, so you need to find f of x at each one of these points. For example, what is 0 plugged into the function x cubed? Just 0, right? Okay, what is 1/2 plugged into x cubed? 1/8. Plug 1 into x cubed. Plug 3/2 into x cubed. And plug 2 into x cubed. Okay, do we all have the same values for f of x column? So we took the partition points and we plugged them into the f of x. If we look back to the formula for a moment, what we have just determined is, we have just determined basically these heights. This height, f of x sub 0, this height, f of x sub 1, and so forth. Okay, we just determined those heights. Okay. Now going back to our example. Okay, Now give me the trapezoid coefficients. The trapezoid coefficients for, I use capital T for that. 1, 2, 2, 2, and the last one will be a 1, right? So the trapezoid coefficients are, you start with a 1, you have 2's everywhere in between, and you end up with a 1, right? Okay, so if I'm going to be applying the trapezoid method, again, let's look back to that formula, the trapezoid method formula, which is right here. You see what's happening here? The first height is multiplied by 1. The next one is multiplied by 2. You know, we have already noticed this previously. All the middle ones are multiplied by 2, and the last one by 1. So what do you think I should be doing here with these two columns that we just determined? Multiply them, exactly, because this, if you multiply the second and the third columns, basically you're going to have each of the entries within the brackets of that formula. So 0 times 1 is 0. Then 2 times 1/8. You could simplify it, but I'm just going to leave it as it is right now. 2 over 8. 2 times 1, 54/8. And 1 times 8. Okay. In one shot, I want to be able to do Simpson's and trapezoid, so let's also proceed with Simpson's coefficients. Okay, what are the Simpson's coefficients? You should always start with a 1, 4, and always end with a 4, 1 with Simpson's. And in the middle, you're going to alternate 4, 2, 4, 2, 4, 2. In this case, there's only one place to put a 2. Once again, let me show you that from earlier when we determined the Simpson's formula. Based on the Simpson's formula, you remember the coefficients there? 1, 4, 2, 4, 2, and you start with a 1, 4, and you end with a 4, 1. And once again, if you look inside the formula, you will notice that we're multiplying the heights with these coefficients, basically. And up front, there's a 1/3 times h for the Simpson's formula. Up front, there's 1/2 times h for the trapezoid formula. So let's fill the next column then in our problem. Now we're going to do f of x times s. So I'm going to multiply this column with this column and write the entries in the last column. So I have 0 times 1. Then I have 1/8 times 4. Then I have 1 times 2. Then I have 27/8 times 4. It should be 27/2, I suppose. And then the last one is 8 times 1. Okay. What I'm going to ask you to do is I want you to sum these two columns. Sum this column here, the f of x times t column, and sum this column here, which is f of x times s column. And let's see what we're getting for those. Why are we summing them, by the way? If you look at the formulas, the formula had sum between these expressions, right? 2 times f of x sub 2, 2 times f of x sub 3, etc. So we need to sum them up to get that what is inside the brackets. Okay, if you summed up the first column, this one, please let me know what you're getting. $17 exactly? Okay. I guess that makes sense. 2 plus 54 is 56/8, which is 7. Yeah. And then plus 10 is 17. Okay, what about the next one, this last column? That's 24. That is correct. Okay, very good. So we got the two columns added. Now, let's get the answer using trapezoid method on the left-hand side here. With the trapezoid method, what was that coefficient up front? Again, I'm going to bring the formula back one more time. The coefficient up front with the trapezoid method was 1/2 times h with the trapezoid method, right? And what was that coefficient for the Simpson's method? 1/3 times h. So remember those two coefficients as we go back and finish the problem that we have just started. Okay, so for the trapezoid method, you want 1/2 times h. What is h for this question? The step size, base of the rectangle, which is 1/2, right? We determined that on the top of the problem, that was 1/2. Times inside the brackets, basically we've done all of that. Inside the brackets is this sum right here, which is 17. So we're getting the answer is 17 over 4. So 4 times 4 is 16. So this is like 4 1/4, 4.25. Right? What was the correct answer? 4. So already by using just 4 trapezoids, we're pretty close to the actual answer. And what about the other one, Simpson's method? Let's also do that one. That one, the formula says that you need to have 1/3 times h. 1/3 times h. H is a half, right? This is our h value. And then the sum, which is 24. Wow, what are we getting here? 24 over 2 is 12. 12 over 3 is exactly 4. So somehow with Simpson's method already, with 4 of these entities used, trapezoids with parabolic tops, let's say, you actually have the exact answer. We know that's the exact answer because we did it earlier, right? When we did integration, we knew the answer was going to be 4. So when we did it with Simpson's method, we got something really close. The bottom line you should remember is when you're doing these questions, the two answers are usually going to be really close. Like if you get 17 for one and 5 for the other one, chances are you made a mistake somewhere. So this is, in a sense, a way to check. If you do it with trapezoid and Simpsons, you should get something close because ultimately you're finding the same area, one with one technique and one with the other technique. Now, I know this question was, you did not need Simpsons rule for this. You could have done it by hand. But let's take a look at this one right here. Now we're in trouble. If you don't know a numerical technique, and since you still don't know something called trig substitution, which is something you're going to learn in Calc 2, this question cannot be done by U sub, basically. You need a higher technique, a higher level method of integration, or we're going to use Simpson's and trapezoid method to integrate this. Okay, for this question, I said use n equals 8. Use n equals 8. And let's determine what would that tell us about delta x or age. Again, I'm using those interchangeably in our formulas. So the length of the interval is 3 minus 1, right? And we're going to divide it by 8. That's 2 over 8, or 1/4. And to make things easy for this question, I'm going to use decimals. I'm going to say 0.25. Okay, 1/4 is 0.25. So on the first column for our x partition points, where should I begin? What is the first number I should put down? It should always be your left end point of the limit of integration, or the bottom limit, which is 1. Okay, what will be the next partition point? 1.25, and go from that point forward, keep adding 0.25 until you have reached the upper limit of integration. So the next one will be 1.25, next 1.5. We keep adding 0.25 to it, basically. And 3. Okay, so we're going to need to find f of x, the trapezoid coefficients, then f of x times t. Now this is where the calculator will be very helpful because there is a way to do this on the calculator very efficiently. Which I will show you in just a little bit. Okay. Now normally, we're not going to do this by hand right now, not even one at a time on the calculator, but normally, at this point, what would you be doing right now? You would be plugging in f of x into f of x, right? And what is our f of x for this question? The square root of x squared plus 1, correct? Just give me the first value there, just so that we know what we're doing here. If you were to plug in 1 into f of x, what would you get? The square root of 2, right? Okay. Now, in a minute, we're going to fill out the rest by using the tables command of the calculator. The trapezoid coefficients are always the same, 1, a whole bunch of 2's. And the last one will end with a 1. And while I'm at it, I'm going to put the Simpson's coefficients as well. Remember, those begin with a 1, 4, and they will end with a 4, 1. In the middle, you alternate 2's and 4's. As you can see, the easiest way to do this problem right now is put your f of x into y equals, and then go to your table and keep entering the x values. Automatically, it's going to give you the f of x values, okay? But there is even an easier way, which I'm going to show you after I answer Amy's question. Yes, please. Did I miss something? Yes, actually, because the left endpoint, like this is like x sub 0, then we have x sub 1. So there are really 8 trapezoids, but the 8 trapezoids end up having 9 partition points, basically. It ends up being 9 partition points. It's always going to be like that. The reason is because you start at x sub 0, and you end up at x sub n. So 0 through n, there are n plus 1 points, technically. But that creates n trapezoids, okay? But the very good point. I'm glad you noticed that, yes. Okay, so like I was telling you, one way to do this is not to go to the calculator and to go to the tables. Yes, you can do it that way, but then you have to manually multiply, right? You have to multiply. Filling the f of x column is not going to be trouble because you have tables command, but then you still have to manually multiply 2 times this, 4 times this, etc. We can even do better than that with a calculator. If you know how to use a spreadsheet, you can already see this is a perfect question for a spreadsheet, which I'm going to show you in a little bit as well how to do this on the spreadsheet. But your calculator has something that is kind of like a spreadsheet. Let me show that to you. Let's open the calculator. There's a statistical editor in there I want to show you about. This is going to save us a lot of time. Just like with the Newton's method, if you remember, we use a table and it just did everything for us. This is pretty much the same idea here. Okay, so one way to do this, as I mentioned, is you go to your y equals, you enter your function there, you go to your table, just put like 1, 1.25, 1.5. It's going to give you the f of x, but then you still have to multiply manually, f of x times 1, f of x times 2, etc. So to avoid that, we're going to go to press the stat key, go to stat 1. Stat 1. If you have any entries like I do, I clear the entire list by going to the top of the list, press clear, and then enter. Go to the top of the list, press clear, and then enter. So we want to start with a completely clear editor. Is everybody with me at this point? Anybody who needs to borrow a calculator? I have an extra one here. Yes. Give it to Petro. There you go. Okay, so go to stat 1, and clear your list. Is everyone with me so far? Does everybody have a clear list? Okay. First, for L1, enter your partition points. I believe they start at 1, right? 1.25, 1.5, 1.75, 2, 2.25. Again, I'm pressing enter between the numbers, 2.5, to 0.75, and finally 3. Okay, now the way we're going to define L2, that will come from the function. So just to give you, this is my L1 right now on the statistical editor. This will be my L2. This will be my L3, L4, and etc. We're going to need 6 lists basically. Okay. To define your L2, here's how I'm going to define L2. L2 will be, normally you want it to function. The function is the square root of x squared plus 1, right? But where is x residing right now in your list? X is residing in L1. So instead of saying x squared, this is what we're going to say. Take the square root of L1 squared plus 1. Yes, how do you do L1 on the calculator? Let me show you. So first of all, to define an equation, like to make L2, L1 squared, etc., you got to go all the way to the top of L2 and then press enter. The cursor must come down before you can define it as a new column, okay? So go to L2, press enter, it comes down. Is everybody with me right now? And how are we going to define L2? The square root of, you tell me, L1 squared. L1 is second one. Just do a second one, it gives you an L1. You don't have to put parentheses around it, just square it. And then plus 1. The function was x squared plus 1 function, right? Now close the parentheses. When you press enter, all of them are evaluated instantly. Oh, I hope your 82 can handle this. Let's see.
Me too.
Let's make it darker a little bit. Okay, stat 1. Okay, did you go all the way to the top? Now press enter.
Oh no.
Okay, now the square root of L1 squared plus 1, close the parentheses. Anybody else having trouble with that? Okay, now for L3, what are we going to enter? Right, this is the trapezoid coefficient, so it's going to be 1, a whole bunch of 2's, and with a 1. Okay. The next column, L4, let me go back to our sheet. L4 was f of x times the trapezoid coefficients. In other words, which 2 columns are we going to multiply for L4? L2 times L3, right? So let's go back and define L4 as L2 times L3. So go to the top of L4, and then press enter. The cursor comes down, right? Then you want L2 times L3, right? So to get L2, the second 2 times second 3. And then you press enter. Automatically, those coefficients have been multiplied with the function values. Okay, what will L5 be? These are the Simpson's coefficients, right? So start with a 1, 4. And then alternate 2's and 4's. Oops, I went too far there. I should have ended with a 1. And then I should delete the other 2. Deletes. Okay. Got carried away for a minute there. Okay. Finally, L6 should be, go to the top, press enter, the cursor comes down. How should I define L6? L6 should be f of x, which is L2, times Simpson's coefficients, which is L5, right? So let's do that. L6 is equal to L2 times L5. L2, which is second 2, times L5, which is second 5. There we have it. Okay, now I know what you're saying. You're saying, well, wouldn't it be nice if the calculator also added things for us? So then we could just make the calculator add everything, right? Well, luckily, we have such a command. Let's first add up L4, right? That was one of the things we want to add, right? We want this sum We want the sum of L4, and we also want the sum of L6, correct? Okay. Now, to do the addition, you can be on the bottom of your columns, or you can just get out of the screen completely. Do it like second quit, and I just need the sum command. The sum command is under second stat. You guys already know the sum command, right? Didn't we do sum of a sequence before in this class? Where was the sum command? Under math, second stat, and then math, number 5. Okay, which column do we want to add up? L4, okay, this is the second 4. And also, I'm going to second enter to reproduce the command, or go back where you got the sum. And which other column? L6, correct? And there is that sum. So let's write them down. 36.0488. And the last column is 54.058. Okay, to finish the question, what will the answer be with the trapezoid method? Take this sum and multiply it by what? 1/2 times delta x. What is delta x in this case? 1/4. So we're going to take this sum for the trapezoid method and multiply it with 1/2 times delta x. And delta x is 1/4. So 1/2 times delta x, or age, which is this number, times 36. Here I use more accuracy, 36.0488. And some of you who got the answer, would you please let me know what you're getting for that product? 4.506. Thank you. And for the Simpson's method, you will take this number, and what will you multiply that number with? The formula said, is it 1/2 or another number? 1/3 times delta x, right? That was the formula. 1/3 times delta x. Again, delta x is once again the quarter. Times 54.058. And again, we're doing more accuracy today, so let me fix these answers. If you multiply them, what did you get? 4.50. Let's say 5. You see how close these two answers turn out to be for this question. Apparently, they're both giving us very good accuracy. And this is a great checking process. Again, when they're close, then you know that you really got something very close to the actual answer. And I suggest we do one more thing. Let's do function integration. What will our calculator give us for this integral? Let's go to FNINT to check our answer. So go to math, number 9, function integration. And we want to integrate, what was the original function? The square root of x squared plus 1, right? Okay, x squared plus 1. Close the parentheses for the square root, comma. Do you remember the arguments for the function integration command? You put the function you're integrating, comma, the variable x, comma, the limits, in this case 1 to 3, right? 1, 2, 3. 1, comma 3, of course, right? Close the parentheses and press enter. So the calculator gives us, let me see, how different is that? 4.504846. So to the number of decimals displayed here, we got the same answer as the calculator, basically, right? So this one was slightly off, but again, both methods are yielding a pretty good answer for this question. And finally, let me also show you using Excel how you could do this. So I'm going to open an Excel file. Okay. You're going to see this is like much easier. Okay, we start with 1. We keep incrementing it by 0.5. But Excel can, I think it can recognize a pattern, and then it will give us all the numbers we need. You see what I'm doing? I wrote the first few. Let me enlarge it so you can see this better. View, zoom. Say we want 125%. Okay. Oh, maybe even bigger than that. Say 150%. Okay. So what I did was I entered just the first two, 1 and 1.25, and then I highlighted to get a little plus sign, the black plus sign, and then drag it down. It fills the rest for you. It sees the pattern. It fills the rest for you. Then to enter this one, I want this to be f of x. How will I enter it? I'm going to put equal sign. Anytime you want a formula in Excel, you begin with an equal sign. Okay, what is the formula? Square root of, just put SQRT in parentheses, x squared. Where's my x residing? In this cell right here, right? So I put x to the second power. Power is like the caret symbol. X squared plus 1. Close the parentheses. That's the first one, the square root of 2, or 1.421. Now you get the little plus sign that will copy the pattern to all the other cells. Get the little black plus sign, drag it down. All the ones are there. Okay, then we want the trapezoid coefficients, right? The trapezoid coefficients are 1, 2, 2. And here I just want to fill a bunch of 2's, right? So I'm just going to highlight the 2's and just continue. And I put the last one as a 1. Okay, now I want to multiply, right? I want to multiply. This was f of x column, and this was the Simpson's coefficients column. I want multiply. I'm sorry, these are the trapezoid column. Thank you. So now I want the f of x times trapezoid coefficients. Okay, so how do I enter a formula? Start with an equal sign. And which ones do you want to multiply? Basically these two, right? So this one, click in that cell, times this little star key from your keyboard, times this cell, enter. Once you have it, you can just get a little plus sign and copy and paste it. It copies the pattern to all the cells. If you want to see what's in the cell, it copies it the way you want it, like B3 times C3, this times that, and so forth. This one is, oops, I should undo right away. I messed up something. Undo. Well, let me do escape. Is that correct? Yeah. Okay, finally, the Simpson's coefficients. 1, 4, and then a bunch of 2's, 4's. And then f of x times s. Oops. So f of x times s. Once again, start with the equal sign. Click. So first click on f of x times. Click on s. Press enter, and then copy and paste it. And if you want to sum this column, right? So how do you get the sum? Just equal sign, sum, open the parentheses, highlight what you want to sum, close it and press enter. And same thing here, equals sum, open parentheses, highlight what you want to sum, close parentheses and enter. And finally, to finish the question, we can come here, say the answer by trapezoid. The answer is equal sign. Okay, the formula has 1/2 times step size, which was 1/4, times the trapezoid sum, and answer by Simpson's. I should enlarge that column a little bit. Okay, the sum should be equal sign, 1/3 this time, right? 1/3 times step size, which is 1/4, times the cell and the answer you got from there. As a matter of fact, once you set up this spreadsheet, you cannot do this with the 83, but now if you just change this column, your f of x column, these are automatically going to change. You'll automatically find the answer to the new problem. So you could create a template like this, and then for every question you're doing, you could quickly check your answers on the spreadsheet. So I think that's really cool that we can do that. Okay, the last example I'm going to give you, I'll ask you to do in the groups. It's the one that I promised you first thing today, which was the integral of e to the negative x squared. Okay, and before I let you go to your groups, just one quick announcement. There is a question in your group activity it has trigonometric functions, like sine of x squared, something like that. Just remember, when you have trigonometric functions, make sure your calculator is in radian mode. Okay, that's important. Make sure you're in radian mode because we assume x is in radians anytime we're doing problems like this. Okay, so I'm going to let you guys work on this question, and then I'll give you the answers at the end of the class. All right, and finally, let me go ahead and give you guys the answer to this question so you can say, you can check your work. Just a little note though, as you're entering e to the negative x squared into your L2, you should enter it as e to the power of negative L1 squared, right? Because your x's are residing in L1, and that's how you should enter the function values, which is our L2 column. All right, here are the answers, at least a sketch of the solution. Again, if n is 8, the interval is 2 units long, 2/8 is 1/4. So your step size would be 0.25, so 0, 0.25, 0.5, and so forth. You should end at 2. That's the end point of the interval. And once again, get your function values from the calculator, our trapezoid and Simpson's coefficients. And let me give you the summation of those columns. By the way, I did things a little bit out of the order here. Please don't worry about it. You should basically have these totals matching, I hope, for f of x times t and f of x times s column. And most importantly, the last step, for trapezoid, a half times step size times the first sum, and a third times step size times the second sum. As we can see, both of them are about 0.88, and that's once again a good sign. You can also check the answer, of course, on the graphing calculator. And again, if in case I haven't reminded you guys, remember for the graphing, for the group activity questions, for the trigonometric function ones, make sure that you are in radian mode.